students, welcome to part 3 of data related issues. In this particular session, we are going to see the second issue with respect to data, that is data quality. So in this session, we are going to learn about what do you mean by a measurement and a collection error, what is noise and artifact, what is precision bias and accuracy, outliers, missing values, what do you mean by inconsistent values, what is actually a duplicate data, and what are the application related issues that we have. So these are the topics that we are going to cover in this particular session. So coming to what is data quality, now generally when we consider a data mining, actually it is just a technique which is applied on certain data collected. And based on these data collected, we are going to perform some analysis. But the thing here is, we will not be knowing the application part of it. Why? What is the analysis that we are going? We are, as a data analyst, I'll be just performing the analysis based on the given data given to me. But where exactly that will be used will not be known priorly. So data mining, in such cases, I can tell that data mining does not actually address the quality issues. Instead, it focus on two things. One is detection and correction of quality problem, which is also called as data cleaning, and the other one is it uses a sophisticated algorithm. So these sophisticated algorithm are capable of handling some or the other kind of issue that we have with respect to data. So data quality here, the data quality issue mainly focus on these two things. One is data cleaning, and those algorithms which could cater the poor quality of the data. Okay, so here these we are going to address two issues. One is measurement and data collection issue, and issue related to application. So what are the issues that occur during the measurement, and what are the issues that occurs during the collection of data, and what are the errors that might occur, or the issue that might occur in both the cases together, and then issues related to application. So when we say there are imperfections exist in the data, these imperfections are due to the following facts. It might be due to the following, that is the imperfection may be due to the human error. Imperfection may occur due to the limitation of the measuring device. Imperfections may be due to the flaws that happen during the collection of the data, or some of the values may be missing. There may be presence of the duplicate data. All these are the reasons through which there might be some or the other imperfections present. To begin with data quality issue, first we shall look into the definition of what do you mean by a measurement error and the data collection error. Later we shall discuss various measurement errors that we have, and also the error that occur due to both measurement as well as data collection. First of all, when I say measurement error, this refers to any problem that occurred during the measurement process. So, for example, a problem where theoretical and practical values differ. That means when you are performing any experiment, you have we have seen that there will be a theoretical value, and when we perform experiment, we will be getting the practical value. So, when we compare these two, in most of the cases, we find little difference among the values that we have obtained or we are having, right? So that such type of error is will be considered as a measurement error. So in this case, if the attribute that we are dealing with are continuous attributes, then we can say that the difference between the measured value and the true value is called as the error. When we say data collection error, it might be the error that occurred during the collection process of the data, so which might include that some of the data might be omitted during the collection, or some of the attribute value may be missing. And it also may be the case that instead of collecting the actual data, we have collected an inappropriate data. Even that could be your data collection error. So for example, consider we are studying or analyzing a data set which contains image of say tiger. In this data set, if it so happens that we get an image of cat which has some physical appearance similar to tiger, but itself it is not actually a tiger, right? So during the collection process, collection of images of tiger, we by mistake have corrected the image of cat, which is having certain resemblance with respect to the tiger. So now that actually is an error, right? So such type of error we call it to be as a data collection error. So first, let us look into some of the measurement error that are there, which commonly includes noise and artifacts, precision, bias, and accuracy. So first, let us look into what a noise and an artifact is. So when I say noise, noise is a random component of a measurement error. So exam that is any distortion involved, or maybe the additional data that is being added to the actual data will be considered to be as a noise. Say for example, let this be the actual time series that we are having, which is a sinusoidal wave that we have plotted by considering various value of a particular measurement. As you can see here, we are having two different lines, which means there are two different calculations that is measured and is being plotted. Suppose consider while during the data collection process, by mistake or somehow mistakenly, we have added few more data to the actually collected data, or while collection we have collected data which does not involve in that particular analysis process, which may so happen that our data might get look like this. So here you can see the difference of this particular image here and this image here. So this is the image of the sinusoidal wave without any distortion present here, and this is the noise that we can see, because which actually way apart from what this looks, correct. So this will be considered to be as what a noise. Generally, a term noise is used in connection with the data that has a spatial or temporal component. Now, the next question arises: is there any way to overcome that? Is there any way in which we can reduce the noise? Yes, we do have some techniques for that. That is discretization, binarization, sampling, etc. So, which comes in the data pre-processing steps. So, we'll be learning these topics in when we are learning about data pre-processing. So this is about your noise, which is nothing but the random component of a measurement error. So a randomly included component. Next is artifact. So what is artifact? It is the data flaw caused by equipment or technique or conditions under which it was considered. So these are the error which might be due to the physical component that we have taken, or which might be due to the condition under which the experiment was performed or the data was collected. So it depends upon these factors. So the common source of flaws includes hardware or the software error, the interference by electromagnetic radiations are the common errors that we are having. So this is about your artifacts. So it is a data flaw or a flaw in the data. Next that we are going to learn is precision, bias, and accuracy. So these are measurement errors with respect to statistics and experimental science. So precision, when I say precision, it represents the closeness of the repeated measurements to one another. So when we perform repeated experiment, how closer the values of each experiments are. So that represents precision. When I say bias, it is a systematic variation of measurements from the quality being measured. So how when I have, well, say consider I have three variables and I'm finding performing the experiment and noting down the result of these three experiments, and in that case how much variation does we see among the three variables is what bias is. And when I say accuracy, accuracy represents the closeness of measurements to the true value of the quality being measured. So how close the result of the measurement is. So when I consider it in terms of statistics, I can tell that precision is nothing but it is equal to the standard deviation. And when I say bias, it is nothing but the difference between the mean of the set values being measured and the known value. So you will calculate the mean value, and actually you know the you already know a value. So the difference between those two is what is your bias. That is why it is called as a systematic variation. What we have considered. Consider an example. So in this example, the substance obtained is 1 gram. We already have the value that the substance to be obtained is 1 gram. And now say consider I am performing this experiment 5 times. Repeatedly I am doing the same experiment, and I am noting down the values, the amount of substance that is obtained each time. So as mentioned here, I have got in first time when I did, I got the value to be as 1.015. Second time I got 0.990, and next I've got it as 1.01. Likewise, I've noted the value. Here, what we have to do now is, in order to find the bias of it, so first we will add these values. When I add these values, I'm going to get it to be, and then I'm going to divide it by 5. So when I'm going to do that, I'm going to get it as equal to 001, and then from to find the bias, it is nothing but the mean value minus the known value. Mean value here is 1.001, and the known value is 1. So when I subtract it, I'm going to get this particular bias of it. So when I calculate the standard deviation for the precision, I'll be getting it approximately equal to 1. So this is how we calculate the precision and bias for a particular given values. So when we consider the accuracy, actually accuracy always depends upon the precision and as well as the bias value. So it is a general concept, and there is no special formula in terms of precision and precision or bias. So example, in archery, when you consider archery, I can tell that accuracy is nothing but hitting the bullseye. When I say bullseye in case of archery, you know that it is hitting to the center part, right? So that is what is accurate. So now let us have a comparison between what a precision and accuracy is actually. So when I say precision, precision say in the archery itself. How closely I'm to the center of the circle, or how close I'm to the bullseye is what is precision. As you can see here, several arrows which are in this case. I can consider that this red circle, the arrows in this red circle, as the precision because they're very close to us. So repeatedly I've tried to hit the bullseye, but these are the places where my arrows been hit at. So now this red part of it, I can consider it as precision. But when I say accuracy, how much of a time I try to perform the experiment, if I'm every time if I'm able to hit the bullseye, then I can tell that it to be as an accuracy, or it to be accurate. So this is about your precision and accuracy. Next, let us move to the errors due to the both measurement and the data collection. So this type of error, measurement and data collection error, includes four types, that is outliers, missing values, inconsistent values, and duplicate data. So let us consider first what an outlier is. So outliers are either data objects that in some sense have characteristics that are different from most of the other objects, or it can be the value of an attribute that are unusual with respect to the typical values for that particular attribute. So the cause for this is the variability in the measurement or the experimental error. So consider this example here. The example here is we have to consider random values from between 1 and 200. So meanwhile, during the process of collection of these values, we have found or we have taken values 199, 100, 101, 102, 104, and 201 as the values. When you see these values, and with respect to what actually you wanted to calculate, we can clearly tell that this 201 actually should not exist in this particular set, because we wanted to calculate numbers from 1 to 200. So straight away I can consider this 201 as an outlier. So that is the objects with unusual attribute values than the rest. So this is an outlier with respect to the second characteristics what I have mentioned here, because this 200 does not or will not come in this particular range, or it shouldn't come, but we have collected it. So now you consider this one, and the rest of the values still here, 104, 99, 100, 101, 102, 104. I can tell that these values are having some similar characteristics because they're very close to each other. Either it might be with respect to the distance or number of differences between the numbers. So they are very close to each other, as their differences is very much less. But when I consider the difference between these two numbers, it is very much more, right? So I can consider this one also as an outlier with respect to the characteristics one represented here, that is objects with different characteristics than the rest. So yes, of course, I agree that one belongs to this particular set, but when I consider distance as the characteristics, with respect to distance, one is very much deviating from the other values, as the difference of these values are very much very less when compared to the difference between these two values, or difference among these values with respect to one, right? So one is having a different characteristics when compared to the rest of the values, and hence one is also considered to be as an outlier here. Hope you have understood why I have considered 1 and 201 as a outlier in this particular case. Okay, so next, let's move on. Let's take the look at what how is the missing value becomes an error. So here, when we consider a large data set, it is obvious that one or more value of the attribute being missed. So this may be due to that the information may not be collected, or it might be that a particular attribute may not be applicable to all the objects. So these are the reasons why some of the values may be missed. But for analysis part, when I consider the analysis, even the missing values become important at times. At in few cases, even the values that are missed might become very important with respect to a particular analysis, right? So what strategy we are going to apply in order to perform analysis in this cases? We have three strategies. First one is to eliminate the data object or the attribute that is whose values are missed. And the second strategy that we can apply here is we can estimate that missing value. And the third strategy that we can apply is ignoring the missing value. So these are the strategies which you can apply in order to perform the analysis. Now consider eliminating the data object. So what do you mean by this? This actually is a simple and effective strategy. That is, you're straight away eliminating objects with the missing value. So but we must be careful, as even if the data is partially specified, it has some information present in it. Suppose the data is missed, but I have a partial information present. In such cases, that partial information also becomes important some at times, right? Also, if many objects have missing values, then a reliable analysis can't be performed. In such cases, we may just omit those objects. So if I have more values being missed, in such cases, what we can do is we can straight away omit that particular attribute of the object. But in such cases, we must also be careful that these objects will not affect the analysis purpose. So let us consider one example and see how actually it works. Consider the employee data set which is having some missing values in it. So let this be the data set given to us which is having some values missing. In this case, you can see here employee name is missing, and in this case, say consider employee ID is missing. Now suppose the data that we want, or the analysis that we want to perform is, say consider I want the name of the employees whose salary is greater than 10,000. So I wanted from this data set, I wanted to take the value, or I wanted to retrieve data such that I want only the name of the employee whose salary is greater than 10,000. So what I do is, instead, since these two values are missing here, will I be able to make a proper analysis in this case? That is what first I have to understand. If so, then what I do is I transform this table into how I need it. So I'll just check whether these two rows, or these two, since these values are missing, I just first confirm that these two rows does not require for me in my analysis. Whether it is required or not, I'll confirm first. For that, what I'll do is, since he's telling that salary should be greater than 10,000, if I see this particular field here, the salary is 5,000. So which means this row is not useful for my analysis, right? And if I see this also, here also salary is less than 10,000 only, which is 8,500. Therefore, what I do is, I even don't want this particular row, which means I can delete these two without any doubt, and I can form a new table, right? So after elimination, what I do is I'll take up this particular new table. Now from this new table, I'll be able to obtain the required answer for my analysis. So this is what is your missing value with respect to eliminating the data objects. In spite of eliminating these two data objects entirely, completely, my analysis will not go wrong, because I want only the name of the employees whose salary is greater than 10,000. As in this case, salary is 5,000, and in this case, salary is 8,500, which is both are less than compared to what we require. So this is how you can do. You can, if First, I'll see whether that missing data is very much important or not. If it is not, I'll straight away eliminate it. That is what is eliminating the data object. And let us go for the second case. Here, what we are doing is estimating the missing value. So what is this? Let us see. If the data set has missing values, but if we are able to derive a kind of relationship among the values present, we would be able to estimate the value. So here, say I have the example. They have been given with a particular data set or a sequence in which two of the values are missing. First, what I do is I try to obtain a kind of relationship among the data objects present here. When I see here these data 2, 4, 12, 14, 16, it looks like as if it is a even number list whose value is starting from 2 and goes till 20. So, and there are two values missing here, from which I can guess that the value missing here might be 6. It might be 6, or it might be 8, or it might be 10, right? So what I do is, so with this observation of mine, I can tell that I might have 6, 8, 10 being present in these two places. 6 I'll have in this place, I might have 8 or I might have 10. So for that, what we do is, if it is a continuous attribute, in some cases what we can do is we can take average of the nearest neighbors that is present. So as in this case, what I do is, say consider I will fill say consider I will be filling 6 here. So say I will fill 6 here. Now, in order to fill this particular position, as mentioned here, I would take average of these two. What is average of these two? 6 plus 12 is 18. 18 divided by 2 becomes 9. If I try to fill 9 here, that might not be possible. One case why it is not possible is because this are all even numbers. When I fill 9, it becomes an odd number. So what do I do in such case? In such case, I'll be taking either 8 or I'll be taking 10. Any one I'll be putting it there. Okay. So this is possible for not all, for all cases, but only for the few cases. Now, if it is a categorical attribute, what I'll do is I'll take the commonly occurring value and I'll be putting it there. So when I say commonly occurring, it is nothing but frequently occurred names in that particular list, and I'll be taking that, or I'll be estimating it. Say now here, this again with respect to the same thing, I have a database being given here. What we have to do is we have to estimate the values for this particular position and also the other position. So how am I going to do that? So this is what I have to do. This value and this value I have to identify now. So is there any way in which you can do it? For that, what we have to do is we have to first analyze this particular table. So let this be the observation that we have made. So I have made the observation that all females are assistant here engineers in this particular case, and the females or assistant engineer salary is less than 10,000. That is the other observation. And also one more observation is this: males, all males are having salary greater than 10,000. And one more observation that we can make from this is those with salary greater than 10,000 are associate engineers. So based on this observation, now I'll try to fill these two columns. Say since salary is 15,000 here, and he is telling that I have to find the gender, right? So since males have salary 10 greater than 10,000, so since the salary is 15,000 here, I can tell that this field should be filled by a male. And here also I can see that generally females or assistant engineer salary is less than 10,000. So since and those who are having a salary greater than 10,000 are associate engineer, so which means since salary is 12,000 here, this should be associate engineer. So this is how I can make the estimation. Okay. So next is about the missing values. So what you will be doing when you have some of the values being missed, in such cases how we will be performing. So next is ignoring the missing values. So suppose if if the attribute or the object whose value is missing of not much important with respect to the analysis being carried out, then we may ignore those values. So this kind of strategy can be applied for clustering. Suppose consider we have a cluster of objects, and now we have to find similarity among them. And say consider one or more objects of the pair of values is missing, or a few object attributes are missing. In such cases, we shall ignore such attributes and consider only those attributes whose value is present to find the similarity. So next is inconsistent values. So in case of inconsistent values, many a times data we have will contain some inconsistent value in that. Example, the address field. Yeah, here we know that every address field will have a zip code, right? So which is unique for a particular area. Say consider the area mentioned is say Kerpuram, and zip code is written as 560066. So now here both of these have a mismatch. When the postman takes this particular letter, he sees and he finds that while sorting the letter, he will be confused because it is written Kerpuram and the pin code is 66, but the actual pin code for Kerpuram is 36, right? So in such cases, what we can do is, if the postman is wise, what he'll do is he just make the 66 as 36 and he'll sort it, or else what he can do is he will return back to the original address, or the address the letter who has sent that particular address. So in such cases, in when we have inconsistent values, what we have to do is we have to actually detect it and we have to correct it, and there are certain ways in which we can be possible. Okay, so next is duplicate data. So duplicate data, a data set may include data objects that are duplicate. So for example, receiving the mail twice. This may be due to the reason that the person's information may be stored twice in the database, right? So main issue to be addressed here is identifying whether there are two different objects which actually represents the single object, and also care must be taken to avoid accidentally combining the data objects that are similar but not duplicates. So here, let us consider an example. And in order to overcome this particular duplication process, the process of dealing with such issues, we call it as deduplication. So what is deduplication here? Deduplication is nothing but process of dealing with the issues with respect to duplicate data. Say consider different objects referring single entity. I have a data set of an employee data set which is having some duplicates in it. As you can see here, this particular row and this particular row is actually representing the same data. What I do is first I'll just see the compare the employee ID. Employee ID is same, and since employee ID is same, I'll not come to the conclusion that the entire row is same. I'll just see with the employee name here. If I see I'm having employee name as well, it is same. And when I see the salary, salary is also same, which means these two objects are referring to the single entity itself. So in such cases, what we can do is we can merge them and prepare a new table like this without any duplication. So this is what is different objects referring to the single entity. These two are different objects with respect to the table or the record data what we have considered here, but they are referring to the same entity, and hence I merge them and I put them into a single column and the new table will be prepared. So there might be one more case. We have to take the care against the accidentally merging of data. Says consider the same employee set, and here when I see if I see the employee ID, I feel the employee ID, I know that these are different employees, but when I see employee name is same. So also I'll see the next column, salary, where salary is different. So now here, since employee name is same, it doesn't mean that these two are same entity, so we should not merge them. Here employee name is same, but it refers to different entity, and hence it will not be merged. The table will be taken as it is for the analysis purpose. So this is what here we have to take utmost care with respect to the duplicate data. Sometimes the duplicate data present might be representing the same entity, as in this case this name is duplicate here, but these two are different entities which I cannot merge. So this is the problem that we have with respect to uh, duplicate data. Now the next is data issues, data that is issue with respect to the application. So here, data quality issues can be considered from an application viewpoint. The issues pertaining to the application level includes timeliness, relevance, and knowledge about the data. So first we'll consider what is timeliness. So timeliness here refers as the day progress, the data becomes older. Yes, sir. So the data that we had today might be older data for tomorrow. This will be with respect to, especially with respect to the online transactions, right? So if data becomes out of date, then the models as well as pattern related to that data also becomes out of date. That is the problem with respect to the time factor with respect to any data set. So example is the data or information related to the current online transaction is older for tomorrow. That is true. So whatever transaction that we have made today becomes a older data for tomorrow's transaction, right? So the next issue is relevance. The data available must contain information necessary for the application. Consider that I have a particular data set where I'm identifying the accident rate of drivers, and this is the data set I'm having. Say for the say consider I am performing the analysis of I'm finding the accident rate of the drivers based on their age group as well as on the gender. So I this is the data set that is given to me, and they've asked me to perform the analysis based on the age group and based on the gender. And if I see this data set, data is there regarding the name of the driver, his salary, and number of accidents he has made. But actually, what I need here is I wanted the gender and the age information, which is missing from this particular data set. So that is what is relevance I'm talking about here. So whatever data given to us must be relevant for the analysis. This data is not actually relevant for the analysis. So what is the relevant data then? So if I had a data set like this, in such cases I would have made my analysis very easier. So I have in this data set I'm having age as well as gender. So based on this, say consider I'm going to make this analysis based on the age. I have made the analysis that those in between 25 to 30 years, the number of accident is very less, whereas the drivers whose ages are more between 35 to 40 is having a more accident rate. Say consider based on gender also I'll make the analysis. So male drivers have more accident rate when compared to the female drivers. So this analysis was possible because of this data set, and the same thing wouldn't be possible with this data set. This becomes the irrelevant data for the analysis that they've asked to do. Okay, so next is the knowledge about the data. When we consider knowledge about data, generally if the data set contains a document attached with it to data represent, it will be helpful for the analysis. So I have been given a data set, and also if I have some of the documents related to this, extra document related to this, then it will be easy for me to perform the analysis. So in such cases what happens is the analysis depends on how detailed the document is. For example, we know that when we install every software, we at the end of the installation we have an option to check this readme file. It is fact that many of us won't read it, but yet a few it becomes very important in some cases. What does this readme file generally consist of is it will have information regarding how to use that particular software or how to open that software after installation. So generally when since we might take the help of our friend or someone else who have already installed this software, we will be ignoring this, but this actually is the knowledge about data what I'm talking. So such data if it is present, it will be helpful for the analysis purpose. So this students, this is about the data quality issue that we had. Um, Thank you.